Hi, in this video we're going to discuss about pointers. Pointers in C. So pointers in C are variables that are going to store a memory address. But what does that mean? When you make a program, the system needs to store the data of your application somewhere and stores in the computer's memory, the RAM, the random access memory. It's a place that can hold the value of those variables, constants, and other data while your program is running. And it does that by writing in tiny units called bytes. So, if I open the first example we're gonna see tonight, which is this one, you have a declaration of an integer called a, and I'm gonna print the address of a. So what this program is doing, was telling our system to do, is, bro, I need a space in memory, and I need an integer space of memory. I'm gonna talk about the spaces of memory because it can take 1 byte, 4 bytes, some take like 6, 8. It's different. So he's saying, bro, I need space in memory because I'm gonna store a variable there. Right? Okay, I store this space in memory, and it's okay. But what's the address of that space in memory? And to get the address of the space in memory, we use this operator here, which is the address operator of a variable, which is this ampersand next to the variable's name. And you're gonna print the address of a. So whatever this variable is stored, the program is going to return the address for us, and is using this specifier here, which is the pointer specifier. And since pointers store a memory address, we specify this is a pointer because it's a memory address, even though we haven't declared any pointer here. So let's just run this program. Example 1, and you see you have an address of a, which is this address here. And if you run the program again, we got another address. So first our system stored a space in our memory for that variable, and then the program finished. So it started another when I started it again. And that's it for memory address, basically. So that's just 1 byte that we're getting here. But the integer type of data takes 4 bytes. So what's happening here? This memory address here is just like the first address of this variable, because the integer has 4 bytes of memory usually. So this one here points to, it's the first byte, and the program knows that it should look for the next 3 bytes after this one to get the full value of a. But when you ask for the memory address, it just returns the first one. It works like that for strings, which is array of a char in C, and that's it basically. So let's go to the fun part, which is the part of the pointers. Let's go to the next example, example 2. And this one, things get more complicated, kinda. They don't get more complicated. We declare a again, which is an integer, gonna take 4 bytes, and we declare the pointer. To declare a pointer, what you have to do, you have to specify the type of the variable the pointer is gonna point to. This star here is gonna tell the compiler it's a pointer, and this one here is just be the name of the pointer, whatever name you want. So we have a, and then we declare a pointer to an int. Why we have to specify the type of the pointer? We're gonna see something that's called dereference. And when you're gonna dereference a variable, we need to know the exact size of that variable, because like I said, the integer in this example takes 4 bytes. If I just get the first memory address, I'm gonna lose the other 3 bytes of information. So when I take a pointer to an int, I know that I'm pointing to the first memory address, but the other 3 memory addresses that come after are equally important when I'm gonna dereference to get the value of A. So I'm getting ahead of myself, but let's keep it on. We have a pointer to int receiving the address of A, and I just make this function here so you can see that when you gonna like create an argument for a function that's gonna take a pointer, you declare just like you declare a normal pointer here. You say the type of the pointer, the star to specify the pointer, and the pointer's name. Then you can pass memory address for this function. So here I'm storing the memory address in the pointer, and then I'm passing this value of this pointer, which is the memory address of A, to this function. And this function is just gonna print the pointer's value. See, the pointer's value, not the memory address of the pointer, because the memory address of the pointer is not the memory address of A. We are interested in storing the memory address of A and B. That's why you're just taking the value of B here. So let's run this program. Example 2, and you can see the value of pointer is this one. So that's the value of the address of A. Okay, let's go to the next example. Example 3. So in this example, I'm just showing you that the pointer can take 2 different values of 2 different integer type of variables. So in this first here, we're gonna print the memory address of A and then the memory address of B, and I'm gonna store the memory address of A in P, and I'm gonna print the value of P, and they're gonna store the memory address of B in P, and I'm gonna print the value of P, just so you can see that the pointer here first is gonna store the memory address of A, then gonna store the memory address of B. So the pointer can actually like exchange the variable it's pointing to. It's like the pointer is first being A, and then the next moment it's being B. And that's what is cool about pointers, like a variable of a variable. That's really cool. So let's just run this program here. Example 3. And you can see they have the memory address of A, memory address of B, and they actually really close here. Whoa. And memory address of A is gonna be this one, and memory address of B is gonna be this one. That's the really close because of this thing called stack. Okay, so you can see the first P points to A, so it's gonna have the value of the memory address of A, and then points to B, so it has the memory address of B. And let's go to the final example, which is gonna dereference the pointer, which is the cool thing about pointers, dereference. There is pointers arithmetics too, which is really cool too, but the reference is the most important thing about pointers. A and B again, one the value is 10 and the other the value is 5. B is gonna first point to the memory address of A, and then it's gonna point to B. And when you're gonna dereference a pointer, you're gonna call the pointer's name and this operator here, which is operator dereference. See, the big difference here, it's this one. When you're gonna declare the pointer, you're gonna put the star next to the type and the name of the pointer. Then you have your pointer. When you're gonna dereference, you're just gonna use the name and the star next to it. So what this thing here will do is take the memory address of A, and you're gonna look for the value of the memory address, and you're gonna return here. So this one here, it's a pointer to P. Which memory address the P is pointing to? It's pointing to A memory address. And which value is stored in this memory address? It's 10. So it's going to take this 10 here and it's going to return here. So that's basically what pointers do. First, P is going to return the value of A, and then it's going to return the value of B. Which is cool about dereference, a pointer, is like you have a variable. It's like P is the same thing of A when you dereference. Every time you're gonna, if P is pointing to A, every time you call this thing here, it's like you're calling A directly. But if you, for any reason, want to change what P is pointing to, it's like P is gonna become B now. And that's really cool because this one here is a simple example because it's numbers, but when you have another more complex thing like a struct that has another attributes pointing to structs or pointing to another thing like strings, is really cool because you can get different types of attributes every time. So let's run this program to finish this video. Quit and example 4, and you can see the PD reference is 10 and then PD reference it's 5. So it's like when you do this like that, it's make it looks like it's not really useful. When you go for more complex structures like structs, you're gonna see that pointers can be really useful, because when you're gonna write a function, you're not gonna be able to pass the whole struct as an argument to a function. You're gonna have to pass the pointer, and as you pass in the pointer, you're gonna have to dereference this pointer in this function to get the attributes of that struct. So that's basically it for pointers. If you want to learn more about pointers and why they're useful, learn structs. Structs are something that is really simple. Learn like I need to pass a struct to a function, and you're gonna instantly see why pointers are useful. I can make a video about that maybe. So that's it about pointers today. Bye.